Putting this in the right light here. If U substitution, what is U substitution undoing? The chain rule, right? I want to make sure you kind of have these things in parallel. So integration by parts is our technique that we're calling it for undoing what we just saw in the warm-up, the product rule. So we'll give a quick proof of the following technique, and then once it's in a box, you'll probably just commit it to memory because you'll use it so often. So do recall that this is, in fact, the product rule in Leibniz notation. I'm going to move things around here a little bit. I'm going to move the u times dv dx and isolate that, and move the other part over, v du over dx. I'm going to integrate everything with respect to x. And these become, the dx's all go away in the various locations. What happened here? What's the integral of the derivative? If we're integrating with respect to x, the derivative with respect to x of uv, we just get uv, right? Well, the plus c is, is swallowed up in these integrals here too, so we're okay. So this is sometimes, even though it seems very, very slick and little and hard to understand right now, you're like, that though is the thing in a box. That's the integration by parts formula, like someone might say, right? And I have a nice picture that illustrates this too, which I'll show you if we have time as well. But this proof is certainly fine. So we start with the product rule and rearranged it to get this, but it still takes quite a bit to unpack what we've even done and why that's useful. So we'll do, with the rest of the period, we'll do a bunch of examples and show you how we can integrate things like x cosine x, for example. Johnny, you have a question about the work on the word?
I was going to say something about it, and I stopped myself.
All right, so anyone need another second to think about what we just said? Ultimately, the thing in the box is the thing we care about, though. But
so
go ahead, Jack.
When you say, like, I'm confused how dv is next to the u. Shouldn't it be like u to u?
Let me see where you're talking about. So, are you okay with this line?
I think so, yes. And then I get lost on the bottom.
All right. So, do you agree that this is just dx's cancel out? You just get integral of u dv.
Okay. Well, like, how does that apply? Like, if I'm looking at the problem, how can it, instead of being like a and then dA, or like b and then dv, it's u and then dv?
Yeah, exactly. Yeah, right. You're like thinking. So, hopefully the algebra is fine. You're fine here, but you're thinking like, what? A u and then a dv? Like, what does that even mean? And the answer is like u and dv will be expressions involving some other variable. So we'll show you in a second. Both of them will be their stand-ins for other expressions. U could be some function of x. You'll see. So, right? Just like u can be some function of x up here. By u and v here, don't we really mean a function of x and then another function of x? So yeah, keep in mind that u and v are not little tiny simple things. They could be terrible things. U and v could be. So how do we decide what u and v should be? It's usually ideal to choose a u value that has known derivatives that differentiate to 0. And we need to have something for dv chosen that has nice antiderivatives. So here's and it's hard to say this before actually doing a problem or two and to recommend to you that this is the good order, but this is the right order to pick this suggested. Once you've picked one, you've also picked the other. So there's only one thing to choose, and that's, how about u? So decide on what u will be by starting by picking maybe a log function. If you see a log function in there, let that be what you choose to be u. Or if there are no logs, choose an inverse trig function. If there are none of those, choose polynomials. So this is not just this is an acronym in order here. Lipit. There you go. And actually, some of those things don't matter. Like exponential or trig, you can do those in either order. It turns out it doesn't really matter, but it makes a better acronym. So but it could be LIPTE if you want to. But and also just in some sense, I don't have to show you this. Experience will just bear this out. You'll see that this is the fruitful order to choose for what to let u be in different. Lipit. So in particular, if you have a polynomial times a trig function, that's your integrand. Let u be the polynomial. That's what we're saying. Choose u to be the thing on the left over the thing on the right in this expression, right? So, or if you have a polynomial times a log function, let the log function, let that be u. Okay. So, for example, x cosine x, for example. There are no logs. There are no inverse trig functions. That's what the I stands for. So let's keep moving. Any polynomials? Yeah, x.
Yes.
There's an x there. So let's let u be x. So we'll let u be x. That like I said, the moment you choose x, the moment you choose u, you've also chosen what dv will be. And this answer is going back to what Jackson said. Is what do we mean by the u and the dv? Well, by the u and the dv here, we mean u is x, and dv is cosine x dx. Make sure you say all of that. Cosine x dx. And then, do you agree that what we're really looking at right now is the integral of u dv? If we let u be this and dv be that, multiplied, you get the thing we're looking at. Now you still have questions about why that was done. The other things, look at the integration by parts formula. The other things that you'll need are, it's up here. The other things you'll need besides u and dv in your life are v. Don't we need v? And we also need du, don't we? So find both of those things. What's du? That's easy. 1 dx. So du is dx here. That's nice. What's v? Yeah, good. We're looking for the antiderivative over there if we're looking for v. Plus c, but we'll worry about that later here. So now I think we have everything we need for our formula. So here we go. Plug in u, v. What is that? X times sine x minus, this is the garbage collection here. I'm just telling you that's what this term will do for you. This cleans up the trash. The integral of v du. So v, that's sine x. Du is x. And of course, what's the integral of sine x? Negative cosine, so that'll actually be a plus cosine x plus c. C, the part A of the warm-up today. Isn't that part A of the warm-up? Where c is 5, right? So you felt it forward, and now you've just felt what it feels like to go backwards on that same process. And just to check, again, just do the derivative one more time with me in your head, and just see what I mean by the garbage collection. So what's the derivative of x sine x? The answer is x cosine x. Oh wait, plus sine x, right? But that's okay, because we have a negative sine x waiting to kill it when we differentiate cosine x. You see that?
Yes.
See how the cosine x kind of serves to collect the garbage from the product rule, the first thing? So eventually it's possible that you could maybe even kind of think through these in your head a little bit, maybe. But we'll stick with this though. As always, no matter what, no matter how crazy your integrals get, you'll always be able to check your answer though. Even now, even when it's terrible. If you're using integrations by parts, when you're checking your answer, you will always be doing a product rule. Okay, so check it, make sure it's right, so let's move on. Oh, I have a thing up here. So choose u at dv correctly according to Lippitt. Differentiate u, integrate v, dv, substitute, integrate, add your c. Well, friends, first of all, it should be startling that we don't know this one yet. Just off the top of your head, that we just haven't come across this one, have we? We've integrated all sorts of things. You might be thinking, like, this is one that should have appeared on that worksheet last night. No, my friends, it doesn't look like it, but this is an integration by parts problem. What is our choice of u going to be?
Natural log e, log bc.
What's our u going to be?
ln x.
Yeah. dv. Yeah, dv will just be, well, 1, but dx, right? 1 dx. So let's differentiate here. So du is 1 over x dx, and v is equal to x. So I put the box on this page here so you can keep looking at it. Go ahead and see if you can finish it off. I'll give you a second. Plug in the things where they go. U, v minus the integral of v du. U v. Does that sound nice? U v minus the integral of v du. Yeah, remember Lipit.
I missed that slide.
Alright, Lipit stands for.
When you're done, if you think you have it, if you feel good about your use of that formula and you're feeling good, check it against the derivative. Like, actually check your answer. Don't ask me. I'm not your answer key. I just work here. Does it work? If you have something that has for its derivative this, you're right. You did it. So uv, what is that? X ln x minus. It works? Yes. uv minus the integral of v du. Oh, come on, that was great, right? X ln x minus, what is this? The integral of 1. What's the integral of 1? X plus c.
Oh, I'm silly.
Yeah? Again, do the differentiation. How does it feel? X ln x. The derivative of that is x ln x, or the derivative of that is ln x, if you want to differentiate the x first. And then, oh wait, times x times 1 over x, which is 1. So 1 is the garbage here. And the derivative of negative x is negative 1, which collects the garbage. Is that a, I don't know if you like my garbage collection analogy. Yeah, Johnny.
Wait, okay, so,
Hey guys.
why'd you get, no, I'm about to, okay. Okay, so if you have integral of dx, that equals x.
Yeah, the integral of 1, the antiderivative of 1 is x.
Okay.
Yeah.
Okay.
Caduce?
Okay. That's what I did. That's what I did.
What did you say, Caduce?
I got like x, ln x minus 1.
Here? Well, I just was simplifying this integral, and x times 1 over x is 1. So if you want to write the integral of 1 dx, you could. But I guess I asked you, where did your dx go? Right? I mean, you have a dx here. Yeah. So if you have it here, it's still here. And you just have like a 1 from this. Well, x times 1 over x. Let's keep going. Let's try another one. I'll give it a try. What do you...
Alright, I can do this.
Yeah, let's give a chance to people to just work on it here. Tell your neighbor what you're going to use for your U before you get too far into this, because you'll be lost at sea if you...
Yeah.
And
Not just, no,
Not here yet.
E would be the antiderivative, which is x squared, which would be 1/3
B is 1/3.
You said last I
No, wax them. So you gotta pull the sword out from, yeah. Alright. Yeah, that's what I was saying. And he pulled it out from the bottom. It is. When they pull out like a really thin, like stiletto, like blade from the middle.
All right, you all get an answer that works?
No.
Almost.
Let you be what?
Minus.
Well, you can put it if you want, but in the end, it doesn't. You have one in the end of your point.
Oh, so you do have. Oh, yeah, it's it. Oh, you get to go again and again.
You won't put it there.
If you do it again, you do this
Right? You know how to find the integral.
That's me, not you. I'm the one that on.
All right, so u is what? Ln x. So that makes v x squared dx. So here we have du is 1 over x dx, and v is 1/3 x cubed. And we're ready to write out our integral here. We'll write it here, I guess. So we get uv, oops, sorry, uv minus the integral of v du. So uv is this times this. 1/3 x cubed, oh, that's a little messy, sorry, ln x, minus the integral of v du. So that's 1/3 x cubed times 1 x over x dx. Did I get, sorry, did I say that right? V. So we'll simplify that first. That's 1/3 x squared
No, I'm a strong independent.
dx.
I'm just gonna start over.
So what is the integral of x 1/3 x squared? It's x cubed, and we need a 1 over 9 here. So how do we do? Again, check, see how this feels, right? What's the derivative of this? Notice that right away when we differentiate this, what's the derivative of this? It's x squared ln x. Yes. Oh wait, but then there's some garbage. The garbage here is the fact that we also have to multiply by this derivative too, right? So we'll get 1/3 x cubed times 1 over x as the garbage. What that is, which is 1/3 x squared. Well, that's the derivative of this. So we're good. That'll knock it out, minus the derivative of that thing. So we're okay. Check the derivative. You don't have to take my word for it. You don't have to do it in your head. Just do it off the side, maybe. Check that it works. So far, so good. This is not on the quiz tomorrow, by the way. On integration 1 through 5. All right. Next. Yeah, actually. Integration 1 through 5. Right, let's stop being practice. All that stuff. Okay. What's our choice of u here? Yeah, this is not an inverse trig function. This is all right. So yeah, I think x is a good choice. So that makes dv cosecant squared x dx. We're kind of making these choices simultaneously. And remember, the other thing we want to make is not just something that is polynomial here. We want something that we know the integral of here, and we do know the integral, don't you, of cosecant squared? That's going to be nice. Okay. I mean, we're at if we come here and we can't integrate that, we're done, right? So Yeah, it's important that we remember like everything that there's ever been to remember. Okay, there you go. Okay, yeah.
So for the whole life thing or whatever, look at whatever, we're choosing, does that apply to not using the product rule overall? Like,
No. I mean, it's just the nature of, think about how the product rule works. The reason we gave you those instructions is because already you've seen why logarithm is a good first choice, because of the whole, like, it knocks out other stuff nicely. But the point is, like, we want something that has an integral to be dv. I mean, just because of the formula that we're about to do, right? This all needs to be put in there, and we need something that is integrable. So let's see, negative x cotangent x uv minus the integral of v du. Can I put a plus there? Is that okay? Uh-oh, I'm going to have to remember the antiderivative of cotangent in a second. That's okay, I think, though. Yeah. Go ahead and try it. The only thing is what you'll have, and you'll get into this kind of infinite process where you keep having to, because you're going to have x as your u, as your dv, x dx. And when you anti-differentiate that, you'll get an x squared. And it won't make it go away, you know? And it'll be like a, feel free to try it. You'll get a true statement. You just will have an integral down here that's worse than the one you started with, right? All right, so, hey guys, stay with me here. So far so good. We just need someone to remind us of what the antiderivative of this is. It's the natural log of the absolute value of something plus c. We need like a 1 over, yeah. And we don't need a negative or anything. Just 1 over sine x and then times cosine. So that'll work. Yeah. All right, good. So check our answer if you like, but I think we're done. Okay? Yeah, by Cooney. Huh? This is just like a thing that we learned the other day. You can get it by thinking about what's the integral of cosine x over sine x dx, and then using u equals sine x. If you want to prove that. I'm sorry, sine. I just wrote it wrong. All right, stay with me here. Let's see if we can do one more before we go. All right, not a huge surprise here that x squared is going to be your u. dv is going to be your e to the x dx. So du is equal to 2x dx, and v is equal to e to the x. So things are going really well. So what do we have? X squared e to the x minus the integral of e to the x times 2x dx. What's the problem, guys? What's the problem? Is this an integral you know? All right, so do the same thing here. What would you like u to be? And by the way, we can factor out that 2 if you want.
It's like the chain rule. Oh my gosh. Alex, like the chain rule.
Yeah, so let u be x again. Now it'll go away. Now it's gone.
Oh my god. Derek, I got you. Yes.
Right? This is a new... All right, guys, calm down. Hey, look, watch. Shh. Guys, stay with me here. E to the x dx is finally something we can take the integral of, right? I know it sounds hard, but I think you can handle it. Minus x e to the x. What's the integral of e to the x? E to the x. So that'll be a plus e to the x plus c. Check the Now, check this out. We've got garbage collection for the garbage that the previous garbage collector left behind now, right? Take the derivative with me, guys. Right? What's the derivative of this? Isn't it x squared e to the x? Oh wait, times 2x. I mean plus 2x e to the x. Alright, but that gets cleaned up by this because the derivative of this is, sorry, did I lose I lost a 2 somewhere. Oh, there it is, 2. But that's okay because the derivative of this is negative 2x e to the x, so that immediately clears up the garbage. But the other piece of garbage from this is negative 2 e to the x. But the derivative of this is 2 e to the x. So that collects the garbage from that. Just take the derivative. I'm doing it in my head. But you do it off to the side, and you'll feel immediately why all of this was necessary and why each time this integral cleans up from the last step, right? So yes, you have to do it more than once, and tomorrow we'll do it many, many times. We'll see. We're going to do more integration, sorry, on Tuesday. So you want one for the road? X squared cosine x. Try that one. Alright. It's been real. Quiz tomorrow on integration 1 through 5. Not this stuff though, okay?
I